I have heard that good. The only one.
Okay, let's get started. Okay, so we already learned how to do return-oriented programming. Now you should have a basic idea what we're doing. We're basically looking for gadgets in the address space and reuse those gadgets. And those gadgets, they could be random bytes, they could be even the data part of the instruction. They're not necessarily emitted by the compiler. So the whole process is kind of like you have some innocent bytes, innocent instructions. You break them down and you reuse the pieces of them and rebuild a malicious piece out of that, right? So several useful gadgets or patterns of gadgets we have is we're going to use in the class. First, if you want to store a value to a register, now you know it's very simple. You put that value on the stack, then you use a pop gadget to do that. And if there are some values on the stack you don't want to use, you want to just skip them, you can also use just a pop gadget, right? Also, equivalent to the knobs that we used in shellcode, you can also have knob in ROP, and you just put the return there. So the return will not do anything. You just go to the next address on stack and look for the next gadget. So if you have if you have the address of all returns there, they're not going to do anything. You will just skip, go to the next one, go to the next one, right? So it's kind of like an offset. Another useful gadget is the stack pivoting gadget. So there is an instruction called exchange. It will exchange the value of two registers. So this is an atomic instruction. And this instruction is actually quite important in implementing a kind of like a lock in this architecture. You implement a lock, and the lock has to have some atomic operations. And you cannot move the one value to memory, then move that value to another register, because that's not atomic. That's why we have this exchange instruction there. If you took the OS class before, you probably learn about this instruction. A lot of lock in the OS implemented using this instruction. So what we can do with this instruction is, if the stack is limited, we only have a very small stack we can overwrite. We cannot overwrite a lot of data there. Then we can do an exchange of the stack register with another general register. Then we are swapping the stack to another place, not original stack. We go to another place we can control. Then we don't have the limitation of the overflow stack anymore. Right? Of course, if you can find a pop RSP gadget, you can also do that. So we actually have a challenge today. You need to use that. Another thing is the system call instruction. They are very rare in the address space. So imagine you write a C program. Do you write a system call? Your program will not be compiled into a system call or int instruction, because your program will not directly make system calls. Your program will call a say library function, and the say library function, eventually there are someone making system calls. However, even if there are system call instructions, it will not be followed by a return instruction directly, right? And because of the encoding of the system call instructions, you also do not find many of those in the address space from the ones that are not really emitted by the compiler. So it's hard to find those. But in shellcode, in those attacks, we still need to make system calls. We open a file, we read something, we send a file, we change the owner, change the permission of a file, those things, we still need to make system calls. So how do we do that? So instead of directly making system calls, we can make function calls to say libraries that are system call wrappers. And then we just need to find where are the functions, right? So actually, next we are going to write a more general ROB chain or ROB shellcode. This one, we are going to open a file and print out the value. We're going to open a flag file, print out the value. So Tuesday, we will only try to make function calls to any function we want. So let me remind you of how we do that in 32-bit in our shellcode. We basically make two system calls. The first one is open the flag file. Then the second system call is send the file. We send that. We use the file descriptor of the open file, which is flag. Then we send the file to another file descriptor, which is std out, which is 1. Then we say some bytes. So by doing this, we only need to make two system calls, open and send file. Usually when you program in C, most people are not familiar with the send the file function or system call. You do an open, you do a read, then you do a write. That will be 3 system calls, right? So here, to make things easier, because we are writing assembly and a lot of constraint, we just make 2 system calls. Okay, so we're going to do that in the 64-bit version and using ROB. Okay, so if we follow that approach, the stack should look like this, right? Then we have a buffer, we have a saved RBP, then we have some gadgets to set up the registers. Then we need to find the address of this gadget, syscall return. Or there could be something in the middle, but those instructions in the middle, you need to make sure they will not crash the program at least. Then you set up the gadget again, then find another system call instruction here. This one you do not need to return because we're only making 2 system calls. So here you don't need to return. The problem is you cannot find a gadget like this. Okay, at least most of the programs we have been looking at, we cannot find a gadget like this. Since we cannot find a gadget like this, we are going to make library calls instead. Okay. So this can be a system call or a library call. This is right now we're going to do a say library call. So consider this say library function as a big gadget, right? It is a big gadget. It's a long gadget with hundreds or thousands of instructions, not the smaller gadgets we looked at before. But it is still a gadget. It ends with a return instruction, right? So we need to put the first system call, the first argument, the address of flag goes to RDI, and this is 5 bytes. By the way, this is 5 bytes. How can we make this smaller? How can we do 4 bytes? It's not important for this challenge, but how can we make it 4 bytes? How can we get rid of this slash here? What if there is a constraint that We only have 4 bytes here instead of 5 bytes. What do we do? How do we get rid of this one?
You can just get rid of it. We'll just run the program. To
Exactly. We need to run the program in root. Then the program will look for the current path and the flag will be there. So then we save 1 byte. So there are some share coding challenges online that your share code can only be. So in our share code, 64-bit, we'll probably use the share code maybe 20 or 30 bytes, right? And there are challenges online. You need to do that in 18 bytes. Or I have seen some challenges ask you to do in 6 bytes. And it's possible. Yeah. Or 12 bytes. Yeah. It's possible. So then you have to save every byte you can find. Even as a flag, it probably is too much. Maybe you create a symbolic link, then it will be 1 byte. A file somewhere, then the file name is only 1 byte instead of 4 bytes, right? Then that symbolic link to the flag file. Then you save 3 more bytes. So there are a lot of tricks you can play. The extreme I've seen so far is like 6 or 7 bytes. What if you cannot create one?
we cannot. Your permission. As a symbolic command is not an necessary program.
Well, of course, you cannot create one in the temp. You can create a temp. The temp folder is writable for you. Yes. Yeah. So our system temp is writable for you. Yeah. Okay, so the second parameter goes to RSI. Then the return of this goes to RAX. And the return of this will be the file descriptor. In this case, usually it should be 3 because std in, std out, and std error, they are open. So we took 1, 0, 1, and 2. So 3 will be available. So some cases you can just hard code say 3 for this file descriptor. Then the file descriptor needs to go to RSI again for the second function call because it's the second parameter. Then 1 is the std out for the SDI. Then RDI should be 0 because this is the offset. The RCX is the count, how many numbers or bytes you want to bring out. This number doesn't really matter that much. You can have a big number because our flag is like 30 bytes or something. So I put 1,000 in here, but I remember in our share code, we're not really using 1,000. Okay. So since we do not have those system call gadgets, this is what we're going to use. That system call return gadget does not exist. So we're going to use the address of open. There is a 64-bit version of that. If you run a program, you do print open, it will be this. Then you do a send file to this. Let's look at this example. This is overflow return 4. You have been hacking this for a while. This one, stack is not executable. However, there's no stack calorie. The buffer is 30 bytes here, that's big enough. Then you just want to, so there is no print flag in the address space. You cannot return to print flag. You have to, you cannot execute a share code there. And this is 64-bit. So you have to use that rob chain to get the flag in this case. So I will give you a template here. And well, you're going to do it right now. Then after we finish this, there's another challenge we're going to do in this class. So this one, let's say, this is a template. This is probably not the simplest one. There may be another simpler share code or rob chain than this. But let me explain how this one works. And you can reuse this one. but you need to find the gadgets and you also need to understand what's going on. So let's say the first goal is to return to the function open, right? Then we may not have a flag there, string. We need a string of flags there, right? One way to do this is because that's a file name of the file we're trying to open. There are many ways to do that. First, you can just do a string on the binary on the library to say if there already exists that string. If it already exists, then you just reuse that. Right? That would be easy. Second, you can put that flag into environment variables. In our case, you can do that. Okay. However, what if on the system you do not have the permission to put environment variables? Also, there is no that string in the executable. Then what do you do? So this is a more generic approach. So we are trying to put the string flag or slash flag in somewhere in a memory address. But that memory location has to be writable, right? It has to be a writable place. So what I'm doing here is I'm trying to put the string flag into the .data section. I'm trying to do that. I'm using a very complicated gadget like this. Move RAX to where RDI points to. So the goal I'm trying to do is to put the string of flag into a place that I know the address. I cannot directly push. I don't want to directly push the string of flag onto the stack, because if I push that, I may not find out where it is. I need another flag, another gadget to find out where RSP points to. Right? We may not find out. You may find a flag, a gadget like that, but here I'm talking about another approach. So here, what we're trying to do is the first gadget we have here is pop RDI return. Okay, because pop RDI, so the next value will be go to RDI, and the next value I put the .data sections value, the address. So .data, I know that is a writable memory location. Then after that, the next gadget is pop RSA return. The next value will be go to RSA. So the string slash flag will go to the register RSA. Then I find another gadget, move RSA to where RDI points to. Then I'm writing the string flag or slash flag to the beginning of the data section, which is readable and writable. Okay. And I'm overwriting something. I don't know what I'm overwriting, but it doesn't really matter. I'm overwriting something. After that, we basically already set up RDI, which is the first register. The first register points to the address of that string. Right? Go ahead.
You can do normal switching for.
You may not find a gadget like that. You can do that. But the problem is after you push, you need to know the address and set that address into RDI. Okay. So you won't be looking for a gadget like pop move RSP to RDI. It could be a long gadget eventually achieve that goal. Right? You may not find a gadget like that. Yes. Now after that, RDI has the string's address. Then with RSI should be set to 0 because it's this one. So then we do a pop RSI return this one. Then we go to the next one is return and open. Right? So that's the very first part of this chain. Okay, looks like that. It could be simpler, depends on what gadgets you find. Okay. You may find other gadgets to simplify this part, but this is just the one way we can do this. After that, we are going to, so the previous bytes are here. Okay, so the last one is open is the address of open. So next, we are trying to call the send file function, and RDI should be 1. So that's why we have a pop RDI 1 gadget. RSI should be RSI in this case should be 3. Okay. Or this one is a more general form. Well, so after open, the return value is in RAX. We want to move RAX to RSI. Okay. Right. But I do not find a gadget like that. Instead, I find this gadget. The gadget has 1, 2, 3, 4 instructions. The first instruction is RAX, move RAX to RSI, the first instruction. That's exactly what we want. But the problem is there are 2 more instructions. Hopefully those 2 more instructions will not crash the program or change anything important. And as we can see here, there is a right shift to ECX, so it doesn't really matter. Okay. Then there is a move. This one will be tricky because this is actually also related to this. We're going to move from where RSI points to RDI points to. And fortunately, this gadget doesn't really RSI. This gadget doesn't really crash the program, at least when I test it. Okay, so as long as this doesn't crash the program, we successfully move RAX to RSI. Then you may find other gadgets, by the way. Then we set up RDX, and we do not have a pop RDX return gadget. That's why we find a pop RDX pop R12 gadget. That's why we have 2 things here. This one doesn't really matter. That's just a placeholder. So after this, we only need to set up. So I can some RCX doesn't really. We do set up RCX here. I said it's like hex 50. But I think even without this part, it should work because RCX will have some value, not 0, then it should be good enough. Then we have the address of some file. After that, we are actually making another system call to exit, which is not necessary. This is another one. Okay. So now we have, I will give you like 30 minutes to work on this one. I already have the slides. I already have the slides on my website. So you can have like maybe 40 minutes to work on this one. Maybe 35 minutes to work on this one. Then we go to the next challenge. Next one is also, it's a little bit tricky. Yeah. So with that, you can see we're trying to find a gadget that to move RSP to another register. Cannot find a gadget like that. I do find a gadget that we can move from another register to RSP. I cannot find a gadget to move RSP to another register. Or push RSP. We don't have it. Not find a gadget like that. So here we have a RDX to RSP. Oh, here we actually have one. Oh, however, this one under with syscall. So that's tricky. This one doesn't under with a return. We need to find one under with return. For this part, I think it's easier to just we can move three there, make things much easier. Instead of moving RAX to RSI, you can just move three because we already know that it will be three. What do you call it? I can find anything. Well, try and say that way. Yeah, because there are many more gadgets you can say that way. Right. Trying to have an option. No, yeah, you already got option. They do the offset. This is on the main. Yeah. This is a symbolic thing. This one or this one? Yeah. They're basically the same thing. Right. So that's a binary. That's a binary. Yes. You just call it a binary name for the group. I think instead of that. Oh, but I need to add an offset. Yeah. So you will need to offset. Binary first, then offset. That way. Thank you. I think it wasn't best to get $1 million. You should do it. Oh, yeah, just do it.
Yeah, we do is on field, we do something. Yes. Yes. It's done. The orientation problem. The orientation problem. We have to do that. Yeah, definitely. This is not about it. We have to do it. It's about it. Well, it's good. Really, the work flow, return, no activity, yeah, no, It's between the consumer, it's like the finding all which we will avoid. It's not automated, but we don't really type the address. Yes, it's a. There are making the APIs to everything, like there are the address and the other type thing. I see. So, the thing that is good to know, what the address you are looking for. Okay. IS. Okay. Let's just make a look. In the library instead of just sitting on the Bible. All right, there's the. No, I'll sit on my, I'll sit in school. The school was confused. Oh, yes. Yeah. Yeah. See that one? Yes, they put the library name there. Oh, okay. Yes. The alternate is for both of them. You know what I mean? Yeah. Yeah. Uh, probably not. Probably the wrong. Yes. We could say talk. When you get along. Thank you. Yeah. No, the source function. It's. Yeah, the instructions name should be copied instead of moved. Yeah.
Yeah, give me 1 minute. I will be there. Yeah, it's probably this one. I think that random change. Yeah, I think that is, I don't remember exactly, I think that was kind of step. But so probably one that we want to, but yes. You can double check. Remember that. Yeah, yeah, that's why I wouldn't say no again. Yeah, I'm looking at this. So we're not going to do that. It's not your comment, I guess.
How fight you first with your papa? Now fight you first with your papa. Oh, I guess there's what we file is three polarity. Um, so you probably want to do that in the file first. From the from the symbol, the library. With your name, with your name, library. Not very good at debugging, but that'd be great. I found when I got to here, I said, "Well, that's really easy to do. So I just breakpoint, which here? At 46. What? Breakpoint. You're out of the code. They're breakpoint there. And if you the breakpoint, you use the SI, then the body one. And the body one blockchain. Yes. Can you find them? You say you did, very free into the thing. Yes. Yeah, now we're find a new artifact free. No, that's wrong. Oh, it's not. Oh, you have that one. Yeah. You find alright, yeah. Which one? You cannot find this standard? I'm not sure about this means something in regular expression. Oh. Yeah, maybe. Yes, it means something given it an escape to it. Oh, yeah. Yeah, okay. Okay. Yeah. And thank you. Yeah, we figure out. Yeah, we feel all the RSI. Yeah. Yeah, we're pretty understand. Well, we don't use any person. You know, where's the return? And we kind of know that. Not very. We visualize that. Never know. We're not having any. Yes, it's okay. Yeah. We don't really need that, but this word is rich in trouble. So after the time, we change that. Yeah, I'm not 100% sure. So it was like, it will make sense, more complicated. So I made part of the problem. We find it, we find it. Yeah. Oh, and no one in the office. I didn't do it. No, collaborate. Yeah, the mouse will need. That's why like what I feel like it. Is it all maybe all five to which is new to like yeah, like not really. All five yeah, all five yeah. We can reduce the freedom. You have to do one. We did pop ideas, pop articles and return. So zero is, so you could just pop ideas, it's zero. And then one is the important. Yeah, yeah, one is what match. From here. Yeah, yeah. One. The price of was putting in flying in as transfer slash one at LAU, which like looking for yes. But now probably. So where are you? You're already open? Yeah, open? And the actually file that in this? Well, because the file that it's looking for is 2F, yeah. 6660, 6167. Then I tried again with it. No, it's not a file anymore. I mean, that place should be the address of that screen. Okay, so I put the address to that screen right here. I set it as a environment variable. Okay. It's set as an environment variable. Okay, then turning off. Turning on your voice. That's good. But that address only look like that. Then I'm running it. The bottom part. Wait, I put some zeros in front of it. But you know, you need that address, right? Yeah, but still, like I said, this address, even if it's correct, it will be the address from. Yes. It will not be the address of the slash flag. We will, I assume you will have a lot of slash there, like. I wasn't thinking to do that, okay. Yeah, yeah, we will add a lot of slash there, kind of involved. Because then we will add some value, I mean, all of those value. Okay. Because you don't know the exact address. Okay, that makes sense. Yeah. So instead, I need to do. Or in equal. still prefer to do it in time. Okay.
Oh, I'm involved. Yeah. Balcony.
Sign on here. Oh, yeah, here. Mhm. But I'm not sure if we have reached the video. Yeah. Video. Oh, really? The library on the planet, the invite. Yeah. Not really matter. Yeah. Yeah. Like, yeah, that's how I. I look at my phone and my file is definitely launch recorded by flag. What is file? I in open 64. Oh, you already in that? Yeah. Okay. It's inside open 64. What's the other one? You know that file directory. Well, if you get a low permission one, you don't understand. You don't have to use that as another dimension. Yeah. Yeah, don't push volume when it's like fall later. Yeah. Anything like you can do with that, and 50 selected comma line. Either trying to load flag instead of flag. And button things up. Let's just examine. Move it on to the point where it's they called it that if we if I run it one more time, I've got a break. Oh, what am I doing? So it could be that I have two different. Oh, because I have a different variable that's just flag floating around from earlier, and that's what it is.
This is correct.
That's correct.
Correct, yeah.
Okay.
There's nothing between there. It's correct.
I'm hitting. I'm hitting flag, but I'm not opening.
Well, first of all, we have the body cannot open that.
Oh.
We don't have, we're not doing pseudo here, so we will not be able to open that. Sure. But we should not build a node file. They will trigger an information. So the area of getting no such file. That could be weird. Yeah, this means what you debug, the first step. What is your sort of status, right? Can I say one more better?
I did it wrong. Which
On the computer, maybe not. The moving part, we talked about the second part. Yeah, assuming the first one.
Yeah.
Correct? Yeah. Anyone getting there? Info? Don't wanna come back You wanna find out? You don't do program? Yeah, yeah, so that one is called data section. So you do this with not there anything. That's about data section in the program. And this tool is helping you to find the gadget. Oh, yeah, then it's basically. No, it is. You can do it. Find this program. Measure average. Yes, we're doing files. Basically, all data section, this samples. Leave that. Yes. Okay, thank you. See the connected into the middle of this pretty divided. Yeah. Yes. I'm not good. Yeah, I mean, also you place the. The thing over and else to the impact. This problem, the actual. Get it to the enumeration. There's a lot of phases in that. And this after yes. When you return it, this. Yes. It's probably a. So this is where. You do this. This becomes a regular. Then looking for 134 on the
and oh, before you move on to that, the table, look, look, oh, yeah, you can feel it. Oh, you don't think about it, yeah, no, 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 no. Yeah, you have to think about it. Yeah. Yeah, 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 yeah. Then, you know, which instruction will serve you. That, I don't, yeah, so the problem. You know, that, top idea I will have. So, top idea, idea I will have. What should be idea? Yeah, I guess, yeah, that's correct. And we, and then, so the things that we, and then, yeah, why not? What, really was, what, is this one? How we got, yeah, correct? Yeah. This is the, Return, right, so return the baby, if it's going. Yeah. Into which one? Into which one? You haven't played that yet? Oh, yeah, we have one. Well. You know what we have it. That's the correct one. You wanna have it? Why you start to have it? That's the meeting. One, one eye. So. Well, maybe that's the argument for like. Yeah, the arrow down there. Yeah. Yeah, we're going to do it. Okay. Yeah. Yeah. Right? Oh, it's pretty. Okay. Maybe. Oh, it's this one. You open this on. Mm-hmm. Oh, yeah, yeah. You can be finish. Finish with John. Oh, you can continue. Yeah. Oh, I forgot. Yeah, you can be finished. You can dump all of those. Moving functions. So, this part is correct. We don't know what to do. These are different things. I didn't see what I did. Double check for the picture I really have. But when I go to it, I'm getting. What was the on? What was the on? No, maybe I used by. When I was messing around trying to shell code, I thought that open stored the file pointer in RAX. No. No. It's fire descriptor. Oh, yeah, that's it. Yes. That's RAX. That's correct. Yes. So I was trying to get the file descriptor out of RAX and into RSI. Okay. Well, then you know what to just only three. Because we know where the three. So maybe okay, I guess I don't understand that. Yeah. So the program when you start, it opens three files descriptors. Okay. Okay. Which is FTP in, FTP out, and the FTP error. And all of them are connected to the terminal. Okay. So they take the file descriptor 0, 1, 2. So the OS stuff. The OS will assign the smallest number available for the program. Now you make a system call of open. And
we will open a file, and OS will assign a file descriptor to the file from the tool. And OS will assign the smallest number available. In this case, it'll be 3.
So I just want to move 3 to RSI.
Yes.
Oh,
Or you
okay.
only just pop. We put this 3 on stack.
Yeah,
and
yeah, yeah, yeah.
pop RSI, return. Yeah, you'll pop.
Okay.
So that makes sense easier because
Yep.
that instruction where it's long.
Yep. And probably with my own instruction, it was a fairly bit more complicated.
So you do a push R, well, you can do a push RX, then you do a pop RSI again. That may work, that work. You find your right answer.
What I thought I was doing, but it seems to be that I'm cycling now, so I'm gonna try this method instead.
Okay, let's take longer. That's it. So, next Thursday, we're putting all the next challenge and hopefully complete. Yeah. There are too many gadgets. Make you think, it's gonna be easier to contour for this one. But then you don't have to do it, and I didn't cover that part. Okay, almost time, but